today we are going through the exam, and you're welcome to ask the questions. But point is that we go through the exam questions basically, or the concepts what were asked, and you are welcome to ask questions. But basically, we are going things what you should have answered there. So first question was about forwarding table, and we were asked to make a forwarding table for router Y. So and you were giving that, okay, we want to identify the network there, mask, next hop router, and outgoing interface. So which networks should go there? So which network should go to our forwarding table?
The ones in the clouds?
Sorry, I couldn't hear you.
The ones in the clouds.
Some of them, not all. We don't have to put all to our forwarding table. Okay, what is forwarding table for? Okay, when we are sending a data packet from our computer, for example, we have to know where it is going. So, okay, it is an IP packet which we are sending out, and there is an IP address of the destination. So destination might be 157.24.22 something, or it might be in this network in this network here. So we have to know, are we going to send directly to a computer which is in a network connected to us, or do we have to send it to another router? So our link layer is not going to send it directly there, and we can't send it directly in the link layer there, but we can send it to the router who is connected, one of the networks which we are connected to. So we in the forwarding table, we have rules which dictate that which direction or which host we are going to send, or which router we are going to send. So okay, this network is connected directly to us. We are the router Y, and we need to know about that. Then we have a network there, which is connected directly to us. And okay, then we have this computer here, which has the one of the private addresses what we have here. And then there's the internet, and 157.24.22 is in internet. So basically we don't have to insert that, but we have to have a rule where to send the IP packet if we don't know its network directly. So let's see if I can type here. Nope. So the networks what we have to have there are, well, this 192.168.14.0. So 192.168. Okay, this is terrible writing with this. Let's try something else. Share. Let's share my display. Okay, and now I can actually fill in the table, hopefully. So we have to have the 192.168.14.0 network there. And what do we do with the network mask? What does it indicate?
We will just write the 255.255.255.0 that equal
Okay.
to 24 bit mask.
Okay, but what does it tell us? It tells that
from the yeah.
Yeah, go ahead, please.
You can choose like 253 open addresses.
Okay, IP
excluding
addresses.
those
Yeah.
network. Yeah.
Yeah, for the network and for the broadcast address. Yeah. So basically, it tells that if this tells that okay, the first 3 bytes here, this part, if the destination address matches this one, then the IP packet matches to this network. So it tells us where do we divide this network mask here, or IP address there. We don't have to do it on the byte boundary as the later task goes there, but basically if the front part here matches, then the IP packet destination address matches that, then it belongs to this network. Okay, do we used to have to send it to another router to access to this network? No, so we don't need to send it to the router. And which outgoing interface we are going to use to access this network from router Y? Which is the outgoing door for the router Y, so where the packet has to go so it can reach this network? It's the either E0. So basically, interfaces are the outgoing doors for our router, which we are looking for. So we are throwing the packet out from the E0 door here. Okay, are you following? Okay, there is a question, please.
Yes, it is. How do you get that the mask is 24 bits and not more or less?
So, okay, now in the task, it said that, okay, we had some number of computers which we were supposed to accommodate in the network. So was the question that there was supposed to be at least, well, we were able to keep 200 computers there. So okay, let's jump a little bit. Okay, later on, there is a question, what is smallest subnet mask to accommodate 26 computers in single subnet? And basically, we can look the net mask as binary number. It tells us how many bits belong to the network and how many bits are reserved for the computers. And now, if we had 200 computers in the network, we need at least 8 bits to accommodate 200 computers. So
Yeah, I understand that. It's just that 200 computers, I didn't see it in the slides now, so I was confused.
Okay, sorry. The exam question is not printed here. So in the exam it said that you had to have up, I think that was 200. Let's see. Well, you can accommodate 250 computers, said the exam question. Yeah, that is where that comes.
Okay.
Yeah. So, okay, how about the next network? This is connected to our router. So what is the network? Okay, please.
I have another question. Do we need to include the 24 mask, or can we just do it without? Because I was thinking here that you can just run the mask without the 24.
Okay, I had a little bit hard time hearing you. There was a strong echo in your voice, but if you answer this or /24, they are both equally correct.
Okay.
Was that your question?
Yes.
Okay, yeah. So yeah, it is okay to say use either one of these are just two different markings to the same thing. Yeah, good question. Thank you. Okay, for this network. So, okay, as the task said that we have to have accommodate 250 computers in each network, so we have the same mask there. We don't have to send the data packet, IP packet to the router because we are directly connected to this network. And to access this network, the router Y is sending the message out through the interface Ethernet 1 or the IP address, which in some cases it's expressed with the IP address of the interface. So you can use the name if there are name or the IP address for the outgoing interface. Okay, if we want to access internet, so typically we have a default route. Okay, when we are sending a data packet, we are going through the forwarding table. Okay, does the destination match the networks which we have, or the computers in the forwarding table?
The presentation went off.
I think your microphone is off.
Very well. Okay, thank you very much. Okay, please don't click share your screen. It's probably stole the microphone. All right. So let's try again. So when our router Y is sending a data packet and it's destined, for example, for this network here. So we are going through the forwarding table. Does it match this rule? Okay, destination address and mask says that they don't match. Does it match the next network what we have there or host? No, it does not match. So we should have some default rule which would then match there and then tell where to send the data packets if they don't match. So let's make a general this now. Any address basically which has not matched the earlier rule, and from this one, direction to internet is through the Ethernet 1 interface. So this is the outgoing. So should we send this to well, where should router Y send this now?
Router X.
Router X. So what is the IP address where we are going to send it? What is the interface, IP address of the interface where we are going to send it?
The one you're pointing.
Yeah, exactly. So, okay, in the exam, please don't mark the router X because we need to actually know the interface, IP address for that interface, because now the router has to do the ARP query for that IP address. So to be able to send on the link layer the data to next router. So that is the router is the IP address of the router's interface connected to same network as our interface here. Okay, is that clear?
Yeah, can I ask something?
Yes, please.
In the question, it also said that the connection between PC1 and router X, there's technically also a network. Were we supposed to not add this one either?
Okay, okay. You can add that. Okay, it is a private address, so you can. I would say that it's okay to add. I did not deduct points from anybody who marked this here. So you could claim that we have a network or we have an IP address here. We could say that we have a single IP address there. And the same. Or we can say that there is a network with the 255 as the question says. That is completely okay. But we don't actually need this because our default rule is already sending a data to the router X, which goes through its forwarding table and actually forwards then it here. So this is basically unnecessary, but if you marked it in the exam, it's not wrong. It's just it is extra, but it's not wrong.
Thank you.
Okay, that was a very good question. Thank you. Okay, so basically, you got the full points with those 3 lines. Okay, Anton has a question.
Yeah, so In the final not exam, the assignment, we have also the task that you should like in the essay part, we should write, we should draw this the same thing like here. And when we do the ping task, like ping the net and the trace route, so we just
Yeah.
get the output of the outgoing interfaces, or is it like the router's IP addresses?
Okay, if you make a trace route, you will get the routers on the way. But still, what you will get, it is a limited view. That is kind of you are doing now, trying to figure out what the network looks like. So if you are using ping, you will see only you are pinging only the host somewhere, and you don't know much. But if you are using trace route, then you will see the routers on the way there, and basically can try to guess the networks on the way.
So if they like, do I see the interfaces of the routers? Because it's like there's like IP
No.
addresses.
Okay. Okay. Yeah. Yes. You see the interfaces which are facing to you, to your direction, basically. They have the IP addresses there. Yeah.
So it's like because like they have when they have similar IP addresses, like they have a similar network, that I can guess that they are in the same network, or they might be that they are even the same router, but like different interfaces. So like it's different IP address, or should I like draw it like as different routers?
Okay. You are welcome. Okay. If you think it's separate router, you just draw it as a separate router. That's fine. But you don't see the outgoing interface to which is facing away from you. You don't see that with the trace route. So okay, but if let's say that host is here, this would in this network, so you would see the network address, what is available there, basically. So you could guess that, okay, behind this router there is this network. But for example, for the network mask, you don't have real information. You can try to, well, if there would be more computers, you could try to trace route them or ping them, and then find out what is the address space there. But that is completely, well, you don't know how many computers is on there. There could be a huge IP space in the network, and then you could find only one computer, and you don't know what is the actual network mask in that network, for example. Okay, did this clear that at all?
No. Yeah, like the network mask, I'm not really bothered about it.
Okay.
I'm more bothered about the IP addresses by themselves. So like,
Okay. So
because,
okay.
Mm-hmm.
Okay, so in the final task, okay, now think what results you got, basically. So look the trace route, look the pings, what you have. Okay, start from the network where you are connected to. You know the network mask for that, and you know the IP address space for that.
Yes.
And then you know what is the first router and the IP address for that.
Yes.
Okay, that is the first part of the task. Then, okay, what are there other routers connected to the same network, what we know of in our network? Should we draw here another router? Or if we do trace route or ping somewhere, okay, we have a cloud network somewhere, can we find out where should we draw it? For example, with the trace route.
Yeah, so there are like 2 outgoings, I think, from the connected router, from the default from our network.
Okay.
So I wasn't like sure if it's like the interface of the current router that is outgoing, or is it like the incoming interface from like facing to our router from the other router, like.
Okay. Basically, you are seeing only the interfaces which are facing yourself.
Mhm.
You are if we are in this network, we are PC3. We don't never see this by trace route or pinging. We see only this interface here. So if we are pinging here, we see this interface and this interface.
Okay, so is it enough only to include them, or should I like somehow try to guess the others, or?
Okay, that is information what we have. So okay, if we are making trace route and this is the first route on which we find, this is the second one. Okay, I would draw a cloud there, a network between them, and guess what is the IP area of that. So from this interface address here. So I would guess that there is a network which is probably something what's looking like this.
Mm-hmm. Yeah.
All right.
Okay.
Very good. Okay, good question. Okay,
thank you.
so Song-Nian has a question.
Yes. I think there is also a subnet between router X and PC1. Is
this-
10? Yes, 10.20.21.0.
Yeah. Okay. We can. Yeah. This is what we have just had here. Sorry. 10.20.21. Okay. There can be a network, but we as a router Y, we don't need that, because if we are doing this using the default route, it is going to router X, and router X is doing independently, again, going through the forwarding table, and it should find its routing table, the entry for this PC or this network. Okay. Did you get that?
Okay, so the 3 line is enough for the router Y, right?
Yeah. 3 lines is enough.
Okay, thank you.
You're welcome. All right. Okay, then we had a number of small questions. So what is a DNS? It's a distributed system to do what?
To
For
give
mapping
out
domains to
the
their IPs.
Okay.
Exchange the domain name to IP address.
Yeah, we want to get from the domain name an IP address. That is the typical use what we have. So, okay, DNS can have also information of the mail server and so on. So basically, it's a distributed database for looking up the IP addresses from host domain names. And it can be recursive or iterative. So we are our host is sending a query, and local DNS server is then finding out from the authoritative DNS server. So from somebody who is responsible for the domain. So for example, if we are looking host name into LUT there is somebody in our organization who is responsible for maintaining that information, and it's not some server somewhere in the world where everybody would upload their DNS records. Okay, so basically the question expected you to tell the basic thing, what is the DNS, and basic things, what it does. You were not expected to draw the pictures for that. So what is ARP?
Trying to translate a target IP address to its MAC address.
Yeah. So when we're looking this and we were sending it to some IP address, we needed to know the MAC address, so the link level address. So on the network layer, we are using IP addresses, but in link layer, we are using using the MAC addresses. So that is ARP. So how about network address translation?
It is used to translate the private IP address to the public address to access the network.
Yeah. So IPv4 addresses have been pretty much run out, and there was a problem. There was not enough IPv4 addresses for everybody. So the wireless home devices or home routers or home access points devices started to provide internal network with the private IP addresses. So 192.168 starting address is a private IP address. It's not routable in public internet because everybody can use that in their own networks. As is 10 addresses starting with a 10. So address translation, network NAT, network address translation is taking the data packet which we are sending out, looking the destination address, destination port, and then it's mapping its outgoing interface and the new port number. So it's basically rewriting the data packet and identifying the internal host from the port number for the incoming data packet. So it's actually breaking the original requirement for the internet, which is end-to-end connectivity. Okay, what is RFC? It's request for comments. So basically what I was looking here, this is what we talked on the first section. So basically RFCs are documents about internet technologies. They are originally request for comments really, but nowadays internet standards are all RFCs. So for example, hypertext transfer protocol, semantics and content is one of them, for example, or FTP, file transfer protocol, mail transfer protocol. They are all standards. Yeah, okay. Sorry, this opened on the other display. So yeah. So what is the task of link layer? usually link layer dictates for us how do we access the network. So for example, if we have a wireless radio environment, there is a link layer protocol which dictates how do we use that. So everybody doesn't shout there together at the same time and how we share it. Then we have the MAC addresses there, which identify our interfaces. Link layer usually have some kind of error detection, especially if we are on wireless medium and so on. Okay, so what is MAC address? Well, we have been talking, it's the identification of interface for the link layer pretty much. CSMI CD, carrier sense multiple access CD, that is the one protocol used to access medium. So this is from the Ethernet. So when the hosts were listening, if somebody is sending data and if there is a collision that somebody is trying to speak at the same time, then there is a detection that we notice that. But basically, it is a link layer protocol. So when does an Ethernet adapter gives a received frame to an upper layer? Well, we can hear, our network card can hear other transmissions on the Ethernet also. So, but we don't give all of them out to our computer to process. So the MAC address must match to our MAC address, or it must be a broadcast message. In those cases, it's given to the upper layer. Okay, packet switching versus circuit switching. Okay, these are not directly the questions there, but these are the ideas what was asked. So circuit switching is the original telephone network, basically. When you called somebody, there was somebody to connect the wire to the destination. And hey, that works great. But in time of internet, we don't send data all the time. We are sending small data packages when we are doing something, but the rest of the time, there is no point to keep a connection. We can share the connection with others. So packet switching basically shares the resources. Okay, so circuit switching can be very useful if we have a lot of data which we have to have reserved resources for all the time. So if the network is heavily loaded and we are sending full blast of data, the circuit switching could be a correct solution for us. But typically in the age of internet, packet switching is what we are talking here. So what are the layers in the Ethernet protocol stack? We have application, transport, network, link, and physical. So network is the IP link layer. We're talking about the MAC addresses. On transport layer, we are talking about TCP and UDP. On application layer, we are talking about application protocols. So for example, if we are making our own game, we have our own protocol for that. Or we are making our banking application, there is a banking protocol probably how things work. So what are edge devices in the network? edge devices are something which are in the edge of the network pretty much. So your computer, your cell phone, your server or somebody else's server, those are also all edge devices. In the network core, we have the core routers which transfer the data around there. Okay, then there was question related to peer-to-peer. So, and server client paradigms. So server client is the traditional way. We have a server which typically has a fixed IP address or name. We know where to find it. It can be lu.fi. So when we are going to universities' web pages, we know that we write www.lut.fi and go there. But in peer-to-peer paradigm, we have hosts which are serving data to others and are getting data from others, and these come and go, and there is not necessarily any fixed host there. And of course, if we are thinking a server somewhere, it is using data bandwidth from the network. So typically, if I set up a server, I have some network connection there, and there is a limited bandwidth. Let's say that I have a 100 megabit connection in my home, and I have a server there. So if it's very popular, it might be that a lot of resources of my network connections are used to that. So, but if the data is shared in a peer-to-peer manner, there is more capacity as the link capacity of all the participants are typically shared there. So we can have much larger bandwidth serving the data in the internet. Okay, video streaming, what we are using in the internet, it needs buffering because there are delays and jitter in the internet. So that our film doesn't stop when there is small hiccup in the network. So for there is this DAS protocol for streaming video, which is used a lot nowadays. Okay, then we had a question about what is the smallest subnet mask to accommodate 26 computers in a single subnet. So question is basically how many bits do we have to borrow from here, from the end, so we can have 20 computers. So I typically calculate together that, okay, 2 to 0 is 1, 2 to first power is 2, to the second power is 4, and so on. But it's enough to remember. You can just count the multiples of 2 here. So to accommodate 26 computers, we will need 5 bits. So 2 to 5th power minus 2 is 30 usable computer addresses. So in the questions, what I have in the exams, I always have something which is not taking the -2 account there. -2 is that one is reserved for the network address. All zeros is reserved for the network, and all the ones is reserved for the broadcast address. So those which should be received by all the hosts in the subnetwork.
And what about the router?
Okay, router can have any address. We can take any of the address. We can have our network can have just routers there if we want.
When
So,
we say 26 computers, it means 26 plus router or including the router in the 26?
Okay, it is including. Okay, I mean that. Okay. Okay, router is basically a computer also. So if the question how many bits we need to accommodate 26 computers. Okay, all right, very good question. In this network, okay, one address is reserved for the router here. So if I said that 250 computers, okay, basically I meant that okay, router is one of them basically, but that's good to take into account also. So router will spend one of the addresses from there. If you have in this question, there is we are not actually saying that our network is connected anywhere. We just want to have space for 26 computers in the network or in the subnetwork. Okay, very important question. Does a sending node host know the MAC address of target server if the server is in another network?
No. Because API only works on LAN.
Correct. Yeah, exactly. Okay, this is very important because sometimes I say that when people don't understand the layered model, they don't think that MAC address is only visible in a LAN, in a subnetwork. Oops. So basically, we see if you are connected to this network, you are seeing the MAC addresses there. So MAC addresses from here can be seen only by the hosts which are connected or the routers who are connected to that subnetwork. Okay, how a switch knows to which port to forward frames?
By using the MAC address.
Okay, what does it do what does it do with the MAC address?
It will learn from the source address of incoming frame.
Yes, exactly. Very good. So switch learns that okay, which MAC addresses are behind each port. So, and if it does not know behind which port the MAC address is, then it floods it all the outgoing ports, and hopefully learns it after that. So, what does a TCP do when it gets three duplicate acts from a receiver?
It retransmits the lost package.
Yeah, it retransmits the data which is buffered, which is not yet acknowledged. It is assuming that the data has been lost there. So this is kind of to make the recovery from lost data faster. Okay, what is the main function of the transport layer? What does transport layer do?
It delivers packets from host to host. No, that's the network. It does the multiplexing and demultiplexing.
Yeah,
no?
it provides end-to-end communication service to applications. So basically, it's from the port to port. So from a process to a process. Yeah, it provides end-to-end service to processes basically. So it takes care that data is delivered, and if it's TCP, it delivers it reliable manner. Okay. So which mechanism then allows a receiver to control sender's transmission rate in TCP?
I think there are some flow bytes in the header, which is basically control window, like how big it is, and if like the TCP cannot, like the sender cannot
Yeah.
send more bits than the current window.
Yeah, there is a transmission window, and the receiver tells the receive. Well, there is a receive window basically. So the host, receiving host tells that, okay, I have this much buffer space. So this is flow control basically. Yeah. Okay. Okay. I assume that all of you know what is the difference between TCP and UDP. UDP is a junk mail. We are sending it out. We have to just write there that, okay, this is going to this address and this port, and that's it. We don't care if it's received or not. TCP brings reliability. We have acknowledgements. We have timers. We are resending if the timer runs out. We are if the packet is not received. Well, yeah, okay, and then we have windowing and so on, which are there, but that's not really the difference there. But TCP provides a reliable data transfer service. So, okay, we talked about TCP window earlier. What does it actually cover, tell us for our connection then?
The speed.
Can you repeat,
Like
please?
the transmission. Yeah, like it determines the transmission speed. If
Yeah,
it's like bigger, then you can transmit more packets in a shorter period of time.
Yeah, correct. So, okay, originally we had very, very slow network connections, and we could send only, well, we didn't have 100 megabit connections. We had 110 bits per second connections or something with modems, which were really slow. And there was a delay, of course, from end-to-end delay when the modems connected to each other and send it data back and forth there. And when our bandwidth grew, we started to have this problem that we could actually send all the data very quickly, what was not which we could send without acknowledgement, and we needed the window to allow us to send more data, which is not yet acknowledged. So we could fill the pipe with the data, so we could get the usage rate to a sensible level. So that is the transmission rate pretty much for us. So very early in the course, we talked about web caches in gateways. So why would you consider possibly have a web cache in your gateway for your company or your organization from the company perspective?
Maybe
Reduce the
there are
congestion
some
levels.
resources that are frequently accessed.
Okay, there was two. Okay, Jacob, please.
Maybe there were some resources that are frequently accessed, so it's easier if they are in the cache.
Okay, that is definitely one reason. Okay, other reasons?
Because of the congestion levels of the network. So it's also a lot cheaper to store them in the web cache than buying a faster connection for more
Yeah.
throughput.
Yeah, very good. So, okay, so if we have the data in a cache, so we can probably access it faster directly from the cache because there is a delay to somewhere in the other side of the world to access the data. So that's a good for our users. But also the network capacity what we have, we can save the network capacity by having the data in a cache there also. So we don't have to expand our internet connection to gigabit for our company. If 100 megabit is working fine, for example, with the net cache. Okay, so basically this is also a reason. Many of the content providers are bringing their contents to the access networks. So if we have a Netflix or other video provider, they are bringing their servers to ISPs, internet service providers. So all the capacity doesn't all the streams don't go to internet for all the users, but there is a data already in the access network for the users. So this is basic mathematics that okay, data is faster available, and we don't have to pay for the internet capacity for transferring the streams from Australia for everybody, for example. Okay, okay. Now we have gone through basically through all the concepts what we had in the exam. So please do ask questions.
I have a question to this web caching. So is it like less expensive for the firms to give us the rights to download the content, because then we are not congesting the network by watching it online? Or is it like still like bad because you have to download it up in front?
Please say it again.
Yeah, so is it like for Netflix less expensive or like better for them, for their business, to give us the rights to download the content so we don't congest the network?
Okay, they don't basically give the ISPs a right to download their content. They actually bring their own devices. At least some of the ISP content providers, they actually bring their own servers for that. In some cases, then we have these content delivery networks, which is another approach where there are these point of present points around the world where the data is then coming. So it's brought that way to closer to users. Okay, did this answer to your question, Anton?
Okay, yeah.
All right, thank you. Okay, Song Nian had a question.
Yes, I have a question about the question: which mechanism allows the receiver to control the sender's transmission rate in TCP? And I think is that the acknowledgement mechanism also could be an answer for this question? Because I think if the receiver will send the ACK message to the sender, and if the sender don't receive the ACK, it will retransmit the message to the receiver.
Okay, let's see what was the wording there. Okay. Yeah, okay. Flow control is what we are looking here. because acknowledgement is basically sent automatically when you are receiving the data and have more buffer space enough. Well, okay, acknowledgement acknowledges that the data has been received. So not just to acknowledge is not quite enough for that.
Okay.
Okay. Do we have other questions?
Yes, I have another question. It's about
Okay,
previous.
good.
I think how is the TCP socket fully identified, and what about the TCP socket? Because this question I searched on the internet, it gave me two versions of different answers. The first one is both TCP and UDP need 4 elements: the source IP, source port, and destination IP, and the destination port. And another one is TCP needs 4 parts, but UDP only needs the destination IP and the destination port to be fully identified. So
okay,
what's the correct one?
Okay, it depends about the question really, but okay. Why does TCP need these sender IP, sender port, receiver IP, receiver port? Let's start from that.
Because it's connection-based approach.
Okay, it is connection, but underlying layers, it's connectionless still. It's using packets there, but connection is built with that information. So, okay, we receive data. We have to be able to send the acknowledgement back. We have to know the port number, where an IP address where it came from, to send it back. So it is connection, and the connection is identified by this quadruple of information. Okay, in UDP, okay, we are sending data and we are not expecting answer. So there is no concept of connection with the UDP. So to identify, okay, same port and same IP can receive UDP data from multiple hosts. There is, but there is no concept of connection there. So the port is identified by just the IP address and the port, or the socket is identified just the IP address and the port number. Okay, did this answer your question?
Yes, thank you.
Okay, thank you for the question. All right, other questions?
I have one more question.
Okay, please.
It was for the task with the peer-to-peer task. There was
Okay.
a question which was like asked if it's like possible to communicate with two Alice and Bob when they are both behind the network. And the correct answer was like, no, it's not possible because like you cannot go through the net. So is it like not possible today anymore to use peer-to-peer connections, or was it like
Okay.
the book correct answer?
Okay. Peer-to-peer, okay, they have to be able to connect to each other, and they have to do it somehow. And if there is a common server where they can find, okay, okay, if you are behind the NAT, you have to initiate the connection from behind the NAT device to get the NAT rule to your local device, network access device there. And basically, if we have two devices which are behind the network address translation, they can both call out, and if they have called out, they have put the rule to the devices. So data coming to same IP address and same port are forwarded to correct place. But now, if the both of them are behind network address translation tables, they need some way to connect to each other, because they both would have to first initiate the connection somewhere. So this makes this here. Well, okay. Then there are specific ways that you can set port which is for example in your home access point which the connection is forwarded to your computer and your application. So plain peer-to-peer behind the NAT requires some help to be arranged. But if they both are behind the NAT and there is no help, that doesn't work. Did I confuse you more, or did that sound any reasonable?
No, because like some students had the answer that you can still connect to each other if they like do it simultaneously. So it's like, it was called punch holding, I think. And that you have, like, if you connect simultaneously, like both nets open the connection and then like they can connect somehow. But I still wasn't like understanding this solution.
Okay, which question was this?
I'm not really sure, but it was like maybe week 3.
Okay, okay. I will check the question and I will get back on the forum later this week on that. All right. Thanks for the question. Okay, this is pretty much the time what we had for this today. I hope that this session has been useful for you. If you want to discuss more on these topics, please do use the forum. Usually, using the Moodle forum is a good place to start discussion, and hopefully the other students are also joining the discussion there. So we are learning here. That's the target. All right. Thank you, everybody, and have a good week.
Thank you.
Thank you, sir.
Thank you.
Thank you. Bye-bye.
Bye-bye.
Hey, sir, excuse me.
Okay.
Yeah, I want to ask, on the exam, we have multiple choice questions, but I think for most questions, I only choose one option.
Yeah, I think that they were single answer questions. Yeah, multiple choice. Circle the correct answer was in the exam.
Yeah, that was the question.
Okay. Yeah, this time there was only one answer expected for each multiple choice question. Yeah.
For each multiple choice question, there is only one answer expected.
Yes.
Okay.
Do you think that there was a question which had multiple correct answers?
Well, there was 2 questions that I forced myself to choose 2 choices because I think it was supposed to be multiple choice.
Okay. Still, yeah. Okay. We were expecting one answer this time. Yeah.
Yeah.
All right. Okay.
All right. Yeah, say no. Thank you.
Thank you. All right. Bye-bye.